And welcome to the Daily Space Weather, folks. Thanks for tuning in. Today's Daily Space Weather video is entitled, Sup, Son? The South Pole, as in the geomagnetic pole, BY Draconis variables, and the GFS snow forecast. I'm your host, Dan, aka smAsho. Let's take a look at the closest star to your likely location, and please leave us a comment if you're viewing from a different solar system, galaxy, plane of existence, timeline, spaceship, solar system, etc. Planet, planetoid. What you're looking at here is three different wavelengths in the UV spectrum: 211, 193, and 171 angstroms. We see zero sunspots, some coronal holes just west of the solar equator, of the solar meridian. And a quick note about wavelengths. Now, this is a diagram of the electromagnetic spectrum, and it's organized in such a way that short wavelengths and high energy are at the left. That would be gamma rays. And large wavelengths and low energy are at the right. That would be radio waves. So these are all photons. And the portion of the electromagnetic spectrum that we're looking at when we talk about angstroms, in other words, the images here are in very tight spectral bands that coincide with the emission spectra of certain chemicals. Now, the ones in this image here, those are all different ionized states of iron, and this is the part of the electromagnetic spectrum. This part right here, the ultraviolet portion of the spectrum, that is where all of those SDO images listed in angstroms are located on the electromagnetic spectrum. So we're looking at photons here. For instance, a solar flare would be a different type of electromagnetic radiation. Photons with a shorter wavelength and higher energy would be X-rays. And for instance, the 10.7 centimeter radio flux is someplace around this portion of the spectrum, 10 to the 0 centimeters of wavelength. So I hope that helps a little bit. We're talking about all different types of photons. You've got radio waves, microwaves. Visible light is the tiny portion your eyes are able to detect. And let's take a little recap here of the coronal mass ejection that we forecasted. Here's the view from stereo A, Lagrange point 5. So here's the raw data from stereo A. And that coronal mass ejection released sometime between 1:39 and 9 o'clock yesterday. You can see some missing data there. Not my favorite thing. And here's the difference image. Now, this coronal mass ejection not expected to be Earth-facing. And you can see a little bit of ejecta on the far side of the sun also. From the viewpoint of Lagrange point 5, Earth would be out in that direction to the right of your screen. So that's Lagrange point 5. Now let's go to Lagrange point 1 to check out the view from the Soho LASCO C3. And you can see that ejecta heading off to the right of your screen, an indication that it will miss the Earth to the west. Next, looking at the solar magnetogram in colorized magnetogram mode. That's just one day of activity. Again, we see no sunspots, no areas of significant magnetic organization happening. Here's a diagram of the solar system if you're wondering where stuff is. There's where things will be in a week as Mercury swings through the Earth-Sun conjunction. Here's a star chart if you're wondering where the ecliptic is. It's going to go through Libra, Virgo, Leo, and Gemini throughout the day today. If you're up before dawn, you may see the moon. And back to electromagnetic radiation, aka photons. The 10.7 centimeter radio flux is at 74 as solar activity stalls a little bit as it ramps back up into cycle 25. So there's the 1-year chart of the radio flux from solon.info to give you context. And solar minimum was back before that chart begins in November of 2019. And there you can see the 10.7 centimeter radio flux. You can see we're right near this 75 line right now. So waiting to see some activity ramp up on the sun. And let's take a look at some HelioViewer movies. We always have custom HelioViewer movies each day on the channel. Here's 171 angstroms. And again, no sunspots. Active regions setting in the northwest. Here's 193 angstroms, and you can see a bit of a coronal hole system there. Really, it's like 3 coronal holes sort of in a line there, crossing the solar equator. Here's 94 angstroms. And we've got an interesting cosmology segment today. We'll get to it after a couple other things. First, we're going to do volcanoes, as there's been an uptick, at least at one location. And that location is Kluchevskoy. So there you can see volcanodiscovery.com. Kluchevskoy now producing a 30,000-foot ash plume. An uptick on the Kamchatka Peninsula volcanism. Mount Abiko on Paramushir Island, 10,000-foot ash plume over that. And the volcanic alert level was lowered to 1 at Asama on Honshu Island. So downtick at Asama. Sakurajima, volcanic ash not identifiable in satellite imagery. It could be erupting, we just don't know. Suwanose-jima is exploding. That's in the Ryukyu Islands. It's producing a 6,000-foot ash plume. Mount Ibu, flight level 060, it's a 6,000-foot ash plume there as well. Popocatépetl exploding down there in central Mexico. Fuego exploding. Popocatépetl producing a 19,000-foot ash plume. Fuego in Guatemala producing a 15,000-foot ash plume. Not sure if Sangay is erupting in Ecuador. Please don't attempt to pole vault the caldera. Revenador is exploding, also in Ecuador. 16,000-foot ash plume above its caldera. And intermittent puff emissions down at the Peruvian volcano Sabancaya are a reminder not to attempt a back handspring over the caldera. It could be unhealthful, and we need the YouTube views. So please press like, subscribe, notify, share, etc. We're seeing a continued lull in earthquakes. The largest of the past 24 was this 5.7 near the Loyalty Islands, near the deep quake capital of the world, Oceania, north of New Zealand, although that one was near the surface at 10 kilometers estimated depth. And let's scroll up the list here. Again, the 7, 8, and 9 magnitude earthquake drought continues, folks. If you're in an earthquake-prone zone, please be prepared, because 7, 8, and 9 magnitude earthquakes typically end in, wait for it, 7, 8, and 9 magnitude earthquakes. So here's a couple deep quakes, one at Timor-Leste, one at Indonesia. They're both just in the 4 magnitude range. Here's another deep one at Papua New Guinea, that one at over 430 kilometers depth at a 4.7 magnitude. Here's a deep one at Colombia, in the northern reaches of South America. Again, it's an earthquake lull and a massive drought of 7, 8, and 9 magnitude earthquakes. Anyway, welcome to the Neo-Renaissance. Check out our own website, smAshomash.com, smAshomash.org. You can find our social media links, as well as links to our stores and forum. So check that out, smAshomash.com. smAshomash.org will redirect you. And again, welcome to the Neo-Renaissance. Welcome to Cycle 25. One of the links you may find would be the links to our Redbubble shop. Perhaps pick up a zipper pouch featuring the dimension of the year, hell. an homage to the year 2020. We've also got a Fauci fraud shirt and a Google bias shirt. If you'd like to pick up one of those, thanks Smash Team. Look for more designs coming soon of various themes. Now, today's smAsho stream is being streamed currently live to Twitch. It's a fantastic streaming live platform. Thanks to our new followers over there, twitch.tv/smashamash. They've got a great mobile app also, which will notify you when we go live. Thanks to our YouTube viewers, please consider pressing like and subscribe. Please consider sharing the content on your social media if you enjoy the content. Tell your friends, foes, science noobs, and science pros about the channel, as we have plans to go full-time, but until our views jump up a lot, we will not be doing so. Thanks to our patrons, since we're paid almost nothing on YouTube, the true source of funding for the content are our patrons. So thanks to you patrons. We'll be updating the credit crawl soon. We usually do it on the 5th of the month. Please consider becoming a patron and increasing the probability that these videos will continue to exist and be publicly visible and free. Patreon.com/smashamash. Let us know in the comments what you thought of yesterday's ringtone drop. We drop ringtones regularly, as I can't use stock phone ringtones as a music producer. Stock ringtones on smartphones are highly offensive to me because they are crap. So I have a tendency to make my own and look for more coming out because, frankly, I need more ringtones on my personal phone. Thanks to our BitChute subscribers. And most of our content is available at youtube.com/smashomash, bitchute.com/smashomash, twitch.tv/smashomash, and you'll find exclusive content on all of our social media sites, so make sure you follow us in all those locations, at least ones in which you're involved. You know, Twitter, Facebook, Gab, Minds, Locals, etc. And let's do a cosmology segment. It's an interesting one. Little side note, Cygnus X3 is at a loud state right now. And you can see it's in its X-ray loud state here. So it's right around here right now. And we're keeping an eye on Cygnus X3 as it's one of the only known cosmic ray point sources. And I would also note that just a couple of days ago, we saw a big series of X-ray transients come out of Cygnus X3, otherwise known as Deneb. It's one of the celestial pole stars, sort of at the other end of the precessional cycle, Earth's axial tilt wobble. Now, today we came up with a quantum number. This time I did it before the video was streamed live. Today's quantum number was 1012, which stands for KZ Andromedae, which is a very interesting binary pair of stars. And they're Draconis variables, which are interesting. We'll get to it in a minute. There are the transient X-ray outbursts from KZ Andromedae, the binary system. And these are co-rotating stars, so they're rotationally variable, and they're the kind of stars that have a lot of star spots. So when we see spots on the sun, we call them sunspots. When we see the same phenomenon on other spots, we call them star spots. So these two have a common proper motion and radial velocity, and they exhibit a synchronous rotation. So it's an interesting pair, KZ Andromedae. They're also variable in terms of their brightness. And they're two quite active stars that have large spots on the surface on the regs. So here we'll give you a quick, oh yes, and BY Draconis variables, they're highly variable stars. And, this particular one here, KZ Andromedae, they're an eclipsing binary as well, so it's an interesting system. Number 1012 on the Neil Gorell Swift-Bat X-ray Observatory, KZ Andromedae. And there it is in infrared light as imaged on the 2MASS. And here it is on SIMBAD, that is visible light. The Draconid variables, KZ Andromedae. And that's today's cosmology segment. We threw that in with a little bit of extra detail there, as solar activity is so low. Let's move on to more data. The GOES X-ray flux is showing us no solar flaring over the past 3 days. And indeed over the past week. No proton strikes on the magnetosphere as measured by the GOES 16. No surprises there. We would have forecasted it if we would have been expecting proton strikes. And next we'll go to the real-time solar wind. And allow me to get back off screen again. So there's the real-time solar wind, and we see pretty uneventful situation here over the past 24 hours. Current data is 3.6 protons per cubic centimeter for the density, and for the speed 422 kilometers a second, as that coronal hole wind stream subsides back down to background levels. The KP index, a measurement of global geomagnetism, currently at 2. Let's look at the magnetohydrodynamic pressure of the magnetosphere. This is the Geospace Magnetosphere movie showing 4 hours of data. And it should be pretty steady here based on the solar wind induction. No surprises there. And if you're wondering what's in my coffee, it's cocoa and cayenne pepper in an Ethiopian organic coffee. So here are magnetic perturbations at the poles, and I wanted to note something here. We see significant magnetic perturbations here south of South America as well as south of Australia. And I've been watching this for a solid 2 years, and I haven't really commented on it. I think the South Pole may have split in two, folks. So you can see significant perturbations there in the southern Indian Ocean, but also south of South America, in the southern Atlantic Ocean. So it would stand to reason that if the North Pole is splitting in two, that the South Pole would do the same. Perhaps we don't have enough magnetometers down in Antarctica. Here are the magnetic perturbations from a global view here. Looking at the flattened out map. And I didn't really want to comment on the possibility that the South Geomagnetic Pole could have split in two like the North one until I watched it for a long, long time, because I refuse to be an alarmist douche who says things that aren't true on the channel. Anyway, there's 4 hours of data of magnetic perturbations over the global scale, and you can see some pulses there coming out of the Pacific Ocean around Hawaii, and we've covered it regularly on the channel. And since we're living through a geomagnetic excursion, we cover this data daily on the Daily Space Weather. If you're wondering what happened around this time of day on a previous day, there's over 2 years of Daily Space Weather videos. Check out our playlists at youtube.com/smAsho/playlists. And let's move on. There's the GOES magnetometer, measuring the magnetism at the F ionosphere layer, which is around 300 kilometers of altitude. And we see spiky sawtooth patterns here. You see these spiky patterns? That's associated with the Earth moving into the South Pole-oriented current sheet. And here we'll show you a diagram of that next. And those arcjet moments are the GOES 16 satellite using its thrusters, which can alter its, in other words, it's creating plasma, which can mess with its readings in terms of measuring magnetism. So you can see the Earth there in the green. North Pole current sheet has just snapped across into the South Pole current sheet. As I forecasted yesterday, there's the latest image, and you can see the Earth's potential field surface source line now in the South Pole. a very wide south pole current sheet covering 180 degrees of the heliospheric current sheet there. South pole magnetic field remains large and in charge. Here's a line of sight field plot. It also shows you the solar magnetogram and the poloidal fields. That blue portion, that's the sun's B field, which also does represent the top pane of the real-time solar wind data. That would be the BT. And another quick note about the BT-BZ. So this is the BT. And to the extent that the North Pole is contributing to it, you would have a positive BZ. In other words, if the North Pole is contributing more of the total field, you would have a positive BZ. And if the South Pole was contributing more of the field, you'd have a negative BZ. So in other words, just to break this down a little bit more, the BZ, so let's say the BT is 8. If the North and the South Pole are both contributing an equal amount, you'll have a BZ of 0. But if the, let's say the South Pole field is contributing twice as much magnetism, you would have a BZ of 6 and 2. Actually, that would be 3 times as much magnetism, but you get the idea. So in other words, if the BT is 8 and you've got a negative 6 for the BZ, anyway, the BZ is the extent to which one of the solar polar fields is dominant. If you have a negative BZ, the South Pole is dominant. If you have a positive BZ, the North Pole is the dominant field, contributing to the BT, the total field. All right, I waded into the weeds there, didn't I? So here's a line of sight coronal hole plot. And not a lot to say about that. We'll also show you the magnetic field plot of the solar corona, a chaotic place. And this will show you closed potential field surface source lines in pink and open ones in purple or black, depending on their location. And let me just check the life of the stream here, as we are streaming live to Twitch. Again, it's twitch.tv/smAsho. Thanks to our followers over at Twitch. Here's a diagram of the atmosphere. It's just showing you things like altitudes. These red letters over here, these are the ionospheric layers, the D layer through the F layer. It's also showing you the temperature of the thermosphere at solar max versus solar minimum, and the penetration of electromagnetic radiation. Next, we'll talk about electrons, and here's a diagram, a simple one, of the Van Allen belts and the altitudes in miles this time. This one is in kilometers. Don't get your units confused, folks. You could crash a spacecraft on Mars. So electrons are known to charge up satellites, and we don't see any charging hazards there. There's the 3-day electron flux chart, and we're still waiting on a big increase in the electron flux. Will it be coming today? And for you new viewers, these N's and M's, they're referring to midnight and noontime, local time for the satellite. There's the 1-year chart of the electron flux, to put it in context. And here's a visualization. This will give you an idea of where you would see GPS errors. And the closer to red that is, the more GPS error you would see. Nothing to write home about there. And you can see we've been way off with the electron content forecast here. And we are expecting an increase. I don't know why they've lowered their forecast quite so much. I think it's going to be more up around here. That's my total electron content forecast. Next, looking at just one layer, it's the ionosphere. And this is an entire day worth of data. Looking pretty normal there in the ionosphere. There's the current image, 10 o'clock Universal Time. Let's do meteorology real quick. Here's nullschool.net's jet stream map, it's the 250 hectopascal winds. And check out the weird jet streams over eastern South America once again. Bizarre jet stream behavior there. An extreme meridional jet stream flow over the Atlantic Ocean, Western Europe, doubled up jet streams over the Atlantic, quadruple jet streams over the Pacific. The jet stream is extremely chaotic right now. And if you think that's caused by carbon dioxide, I suggest you seek a psychiatrist. There are the jet streams of the eastern world. And check out the extreme bend over Australia also. Southern Australia seeing an extreme bend. Looks like a low pressure system. Let's check the surface winds. And you can see a significant low pressure there. Clockwise rotating low pressure. Yes, in the southern hemisphere, folks, low pressure systems rotate clockwise. Next, looking at a Doppler radar map of the U.S. And it looks like it's snowing and wintry mixing over my head. Just what I always wanted before having to drive around Pennsylvania. Sorry, can't tell you where. It's a trade secret. So here's the GFS forecast for snow over the U.S. This one's on Tropical Tidbits. And expecting some extreme snow here, especially in the northern Rockies and the central U.S., especially Nebraska. Although not really that much. And that is the forecast through Monday, February 8th. We don't go much farther out than about 3 days, as those forecasts tend to be nonsense. So don't believe YouTube channels that know nothing about the physics and just show you these models and put it in their thumbnails and make it look very scary and spooky. That's where the GFS forecast expects things to be at Monday, 12 Universal Time, which would be 7 a.m. Eastern Time. Only 2 inches forecasted to have blanketed nearly all of Pennsylvania. Next, looking at the pressure map here on windy.com. We'll move this to the GFS. And we're going to forecast pressure into tomorrow. We'll just let this play. All right, I'm not patient enough for that. We're going to move this forward. There's where the GFS forecast expects pressure to be tomorrow at 12 o'clock local time. That would be local time for me. I'm located in Lehigh Valley, Pennsylvania. I would note that high pressure is dominating the entire northern hemisphere and low pressure dominating the entire southern hemisphere. What is up with that? I have no comment, except to say, make sure you press like and subscribe. Tell your friends, foes, science noobs, and science pros about the channel, and share on your social media, please. We need your assistance. And once we get enough of a following on YouTube, we will go full-time here at the Smash News Network. So looking at clouds here, it's dark. It's too dark to see them. We use the NASA GOES Interactive Weather Satellite Shortwave Radiation Map. A bunch of low clouds here over the Atlantic still, and some low clouds over the Gulf of Mexico as well. Here's the water vapor map of the same exact place to show you the vast differences between water vapor and where clouds are. And we use the water vapor map when the Doppler is not giving us sufficient information. And by the way, this dry mass of air right here is going to rather rapidly push all of this moisture out to the east. Now we've got bonus features, and thanks Smash Team for promoting us instead of fraud on the internet. We're not really big on fraud. And that's part of the reason why the Smash News Network is the least busted name in news. So we've got bonus features here. And the bonus features will consist of us telling you to press like, subscribe, notify, and share, as well as the colorized magnetogram and the solar intensitygram to show you a heapin' helpin' of 0 sunspots. So here's the solar intensitygram. I don't see any dark ombre, do you? And here's the colorized magnetogram. No areas of magnetic organization. Super weak solar activity. And let's do some aesthetics for the end of the video. It's the northwest corner, where there's some activity in a setting mode. Here's 193 angstroms. Here's me vanishing. Here's 304 angstroms. And you see some filaments there. Some of the only activity to view on the sun, besides some coronal holes. And here's my favorite wavelength, 171 angstroms. Thanks for tuning in, folks. Remember, no matter how much the government drives you to drink, don't drink. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back.